Have you ever wondered how a computer actually makes decisions? I mean, how does it go from just blindly following a rigid list of instructions to making complex, dynamic choices on the fly? Well, welcome to this explainer. Today we're diving deep into JavaScript control statements. These are literally the fundamental building blocks of all logic and coding, and we're going to learn exactly how you can transform a machine into something that actually evaluates information and thinks for itself.
Here is our game plan for today. First, an intro to algorithms. Then, making choices with selection statements, followed by looping logic with repetition statements, counters and sentinel values, and finally some coding shortcuts using operators. Let's get right into it.
Starting off with Section 1, Intro to Algorithms.
Before you can write a single line of code, you need a rock-solid plan. And in computer science, that plan is called an algorithm. Think of it exactly like baking a cake. To solve a problem, you need to know what actions to take, your ingredients, and exactly what order to take them in. If you put the cake in the oven before you mix the batter, well, you're going to have a really bad time. In coding, doing things out of order or skipping a step is the absolute #1 cause of frustrating bugs. You can have a beautifully designed app, but it won't hide broken logic. Getting your algorithm right is absolutely critical.
It all really boils down to the big three control statements. Every single script, no matter how complex, can be written using just these three things. You have sequence, which is just your normal top-to-bottom execution. You have selection, which lets the code choose different paths based on active conditions. And you have repetition, which lets the code do something over and over again until a condition is met. That's really it. The most advanced web apps out there are just massive, clever combinations of these three simple concepts.
A quick heads up before we start writing our algorithms, though. JavaScript has a locked-in list of reserved keywords. We're talking about words like break, if, else, and while. You've got to remember that these are deeply protected by the language so it can actually function. So you cannot use these as your own variable names. If you try to name a custom variable true or for, you'll instantly hit a syntax error, and your program will flat out refuse to run. Just keep those off limits in your head.
Moving right along to Section 2, making choices with selection statements.
Think of the if-else statement like a fork in the road. You're basically asking the program a question, right? Like, is this student's grade a 60 or higher? If it's true, the program takes one specific path and maybe prints passed. If it evaluates to false, it completely ignores that first path, takes a totally different route, and prints failed. It's exactly how we make decisions every day. If it's raining, bring an umbrella. Else, wear sunglasses.
So, how does the computer actually pick a path? It all boils down to true or false. And JavaScript has very strict rules for this. Any non-zero numeric value, automatically true. A string with at least one character, also true. But on the flip side, a zero, a completely empty string, or a variable that you haven't assigned a value to yet, those all evaluate to false. Memorizing these exact rules is going to save you hours of maddening debugging when your code inevitably starts making the wrong choices.
Now, what if you want a whole sequence of actions to happen when a condition is true instead of just one? Easy. You just seamlessly group them together into a block using curly braces. This links all your logic into a neat little package deal. Also, if you want a really fast, clean shortcut for an if-else statement, JavaScript has this brilliant thing called a ternary operator. It uses a question mark and a colon to check a condition and pick a value, getting the whole decision process done on one single elegant line of code.
All right, Section 3, looping logic with repetition statements.
This is where we teach the computer to repeat actions. The most basic way is the while loop, which literally just circles back on itself. It checks a condition first, like, is this product less than or equal to 1,000? If true, it does some math and then loops right back up to ask the exact same question. It's like telling yourself, while I'm still hungry, take another bite. The action just loops automatically as long as the condition remains true.
But, this is where things can go horribly wrong. Think about that hungry analogy for a second. What happens if your stomach never actually sends the signal to your brain that you're full? If your loop's condition never becomes false, like if you totally forget to update the variable inside the loop, boom, you've created an infinite loop. It's a fatal logic error. Your code will run endlessly, eating up processing power at lightning speed. On a web page, this completely locks up the user's browser. It freezes, buttons stop working, and eventually the operating system has to step in and force quit the script. It is an awful user experience, so always double-check your exit conditions.
Which brings us to Section 4, counters and sentinel values.
To avoid those catastrophic browser crashes, we have to explicitly tell our loops when to quit. There are two main ways to do this: definite
and indefinite repetition. Definite repetition uses a counter, which is perfect when you know exactly how many times to repeat something, like processing exactly 10 student grades. Indefinite repetition uses a sentinel value. This is like a dummy signal flag, say a user typing in -1, that tells the program to stop. We use sentinels when we have absolutely no idea how much data the user is going to throw at us. It gives our program total flexibility.
When you connect this raw back-end code logic to the actual user interface, the impact is highly visible. A simple counter variable ticking up inside a while loop is exactly what ensures an interactive prompt pops up on a user's screen exactly 10 times to ask for a grade, before automatically moving on to calculate the average. It's the invisible bridge between your back-end structure and what the user actually experiences.
Oh, and here is a massive trap you want to avoid when accumulating totals in these loops: forgetting your initial setup. If you're adding numbers to a variable, you must explicitly initialize that variable to 0 first. If you try to add a number to an unassigned variable, JavaScript freaks out and throws a logic error called NaN, not a number. Always set your starting point to 0, because tracking down a rogue nano error hidden in your codebase will absolutely ruin your afternoon.
Finally, Section 5, Coding Shortcuts Using Operators.
Since adding and subtracting from counters is something we do constantly, JavaScript gives us some elegant shortcuts. Instead of writing out clunky, repetitive math equations like c = c+7, we can use arithmetic assignment operators. You literally just type c plus = 7. It does the math and assigns the new value in one quick, highly readable step. It keeps your code surprisingly clean and way easier for you and your team to read.
We can go even faster when we just need to add or subtract exactly 1, which is basically the backbone of almost all loop counters. We can use the increment ++ or decrement -— operators. But pay close attention here. Placement is everything. If you put it before the variable, pre-increment, it adds 1 before the larger expression is evaluated. If you put it after, post-increment, it evaluates the expression first and then adds 1. It totally changes the order of operations, so choosing the right placement is critical.
But you can't just slap these shortcuts onto anything. There are strict rules. You can only use increment and decrement operators on actual variables, meaning things that can legally sit on the left side of an assignment. If you try to stick a ++ onto a complex math expression inside parentheses, you're instantly triggering a syntax error. The operator needs a simple, clear variable in memory to grab onto.
And that's it. By mastering sequence, selection, and repetition, you've literally just unlocked the ability to make computers think, adapt, and make dynamic decisions based on live data. You have the ultimate building blocks of software engineering right in your hands. So the only real question left is, now that you can completely control the machine's mind, what complex, real-world problems are you going to solve next? Thanks for tuning into this explainer, and I'll catch you in the next one.